I will go on. Hey, Margaret. I will go on and get started. So I am Heather Kirksey. I am the VP of Ecosystem and Community at the Linux Foundation Networking Set of Projects. I'm the former Executive Director of OPNFV. We recently brought together a lot of our networking projects in Linux Foundation together, and so that's sort of, I now look across the networking projects. So just quick hands, who's familiar with sort of any of the projects in this umbrella? So OPNFV, FIDO, Open Daylight. Yes. Okay. Margaret, you don't count. You were on our founding OPNFV board. This is sort of a recap of the demo that I showed yesterday during the keynote session. So who was in the keynote? Let me just see and saw the demo yesterday. Okay, so a little bit of it will be new. So the demo yesterday was focused on the central office. So, I think you've seen a lot of hardware presentations on kind of some edge optimized equipment. And it's an area that we're looking at from the software space. So the idea is that the telecom operators are looking to transition their existing central offices to be more data center-like, to have more white box hardware, potentially OCP hardware in there, to have more common software built on open source. And then that gives them a path to going even further out to the edge so they can take their applications a lot closer to their users. And so, kind of where we started was here, lots of closed, rigid, complex equipment, stuff that's been left over from all sorts of various times in the ecosystem, lack of standard interfaces, all sorts of specialized equipment, all of which have a different acronym or name to it. Sort of where we've been moving is beginning to virtualize a lot of the stuff that used to be, kind of proprietary hardware intelligence into software. Standardizing on more commodity and even open source hardware equipment, virtualizing that stuff, making everything software defined, programmable, and looking ahead, we're also beginning to look at things being cloud native, to go even further, to have more common management and orchestration of applications, and getting just even further edgewards. So we did a first version of this demo at our Beijing summit just over a year ago. And the real focus there was just sort of showing that you could sort of pull together this open source stack to address these things, and that we could onboard a number of applications on there. And we showed both some residential applications and some business applications. And we used Lenovo and Nokia OCP hardware to do that. We showed a virtual BNG application, which is for subscriber management for next-gen services, and then we also showed some enterprise applications. So it was a fairly basic demo, but it was sort of a first start in bringing together a lot of open source projects, some open source hardware, and some open source applications, as well as proprietary applications. So this is the software stack that we use here. And this is for our VCO 2.0, looking at servers and hardware, white box switch fabric that can be OCP, using Open Daylight as an SDN controller, using OpenStack as the primary sort of cloud orchestration software, and then we used Red Hat's distribution of that. We used hardware from Cumulus, MyTac, and Circle B. I'm not sure. There are logos on there. And then going up into the sort of the next level of the stack, we started using some applications that are specific to sort of the mobile core and the mobile edge. So we used some open source things from OpenAir Interface, a evolved packet core set of functionality from Quartus, and then above that some service assurance. And then OPNFV, for those of you who do not know, we are one of these projects. We do a lot of integration of software projects, and we put out artifacts that are sort of flavors of integrated open source stacks for network function virtualization. which are really good for lab use. A lot of commercial use people will pull from the original source of the things we've integrated. We also create a lot of testing tools that we're about to start publishing and packaging separately. And then we also do a lot of CI/CD connections in between open source projects so that we can really get the integration working better. So what we showed on Monday was really a focus on the mobile edge. Moving to that use case, one of the things about residential and enterprise, you can get a lot more agility, a lot more flexibility. We did some work with Intel where we were showing, CapEx and OpEx savings about 30% by moving certain applications into the edge. So you start to look at 5G, going to the edge becomes necessary, because if you start looking at all the applications that are driving that, like AR, VR, drones, autonomous vehicles, the throughput and latency requirements are so stringent that you need to be delivering your network all the way there. So we were focusing on the sort of central office, people placing sort of things in those central offices. So these are not necessarily your brand new greenfield data centers. These are sort of data centers that have been around for a while, hosting different sorts of equipment, and looking at 5G and LTE access. So also, people stop me if you have questions. There aren't a ton of people in the room right now, so I'm happy to have a conversation. Yes? Yep. Whoops, wrong way.
Okay, so the VNF manager, are those the vendor VNF managers, or this is like a generic VNF manager?
So one of the things we wanted to do is we wanted to use ONAP and use sort of generic VNF manager function. We didn't quite get there, so we used Ansible to onboard everything. So just pretty basic vanilla Ansible, but it worked pretty easily and well. No. We just.
The vendor specific were the VNFs and the EMS.
Yeah, the vendor specific stuff was from F5, Expo, NetScout, and Viata. And then Mellanox provided us our switches in the lab.
And then the other common thing was the manager, there's Metmon and the ONAP orchestrator. Is that right? How I see it? And the SDN control?
I believe so. And then one thing, Quartus was also proprietary VEPC that we got connected with Open Air Interface. They just completed their open source EPC a few weeks as we had already started the demo, so we stuck with this one. But as I get into the looking ahead and talk about operationalizing this, we actually already have the OAI open source EPC deploying in our CI/CD system on a regular basis for functional testing of the platform. So that was something Orange actually got done.
And the ONAP orchestrator was the SO?
Yeah, the ONAP orchestrator, let's just say that was something we didn't manage to get to use, but that was something that we wanted to. So this is sort of the ideal aspirational software stack. We weren't, the ONAP community still sort of a little busy on kind of getting their releases out, so we weren't able to get anyone from that community to kind of support us on this, but yeah, that it would be the service orchestrator piece, and ONAP is what if we had some more hardware and we had just a few more ONAP folks. Yep. No, and there's a slide here that kind of shows you for future work and some of our aspirational stuff. Yeah.
Can I ask you another question?
Yeah.
I think you mentioned you've been working with some vendor proprietary.
Yep.
Those, I would think all of those VNFs.
Yep.
Meaning, do you also work with, have you heard about the other project in ONF, which is also more access related?
The Cord project.
Right.
Yeah. So they're sort of, that's another kind of version of looking at the sort of central office use case, that sort of kind of with the idea that their communities have. So this is sort of from our perspective, kind of coming from the LF networking communities of sort of building the stack. It's great to have a number of choices, and open source is kind of the way we look at it.
In the ONAP, do you also look at how you provision the subscribers, or is this more of just management of these devices?
Yeah, so I mean, Margaret might want to jump in, but ONAP is more about the management of the applications. So it's a lot of what might have been in some subscriber management kind of elements out there, but then also we're not quite going all the way into, say, the BSS there, but the ONAP connects back into that if you need subscriber information. Is that
Right.
accurate?
They
Yeah.
do have external APIs.
Yeah.
that
Yeah,
activate.
yeah.
Well, so what I was, okay, so this is where ONAP, OPNV, even Crano collide. So this was just purely, what I gather, the virtual apps are related to CL in this space. Your side, right, on the ONF side is doing all this OLT, virtual BNDS.
Right, yeah.
And
it's more
they didn't address it that way.
Right, yeah. I think
Now, you could imagine once, what's called OSAM is integrated ONAP, and once they get ONAP, you could sort of integrate it all together.
right, I see awesome as like, maybe one of the stack just within ONAP.
Yeah.
Right, yeah,
Yeah.
yeah.
But as Heather said, they didn't get the ONAP orchestrator.
Right.
Yeah.
They didn't get ONAP.
Right. Yeah.
And
Pretty.
so now the issue is it worth doing it here, or is it worth doing it in ONAP?
Yeah. Yeah, well, I mean, the thing is, I think deploying ONAP and showing it working with an NFVI, I think sort of, OPNFV can gain good insight, but I think that there are probably some pieces of work, that ONAP needs to do, right? Like on their own, like specifically around its own feature development, right? Because OPNFV is not going to do any feature development in ONAP, but we can kind of see putting all the pieces together where things maybe don't work as well as we'd hoped they worked when we wrote software. That's sort of been what OPNFV has done from the beginning, right? Which is when we first started about 4 years ago deploying OpenStack reliably and consistently was not doable. And deploying it with an SDN controller and OVS was, even just that basic stack on different hardware. And even at the time, just 3 different versions of x86 hardware just didn't work. So a lot of it was just getting consistency on configuration and install. And as we've continued, we've brought in other pieces of the stack. So, I think it would have been great if we'd had VPP potentially here, but, we didn't. I think trying to figure out where DPDK is supported in OCP is also kind of an ongoing kind of thing we're trying to figure out as well.
Making the slide.
Yep.
That's the challenge.
Yep.
It won't work.
Yep. Whoops, I'm going the wrong direction with my slides. All right, so basically, this is kind of where we're focusing here, which is the CO sort of use case. And obviously, as this kind of continues, being able to, help orchestrate stuff that's getting even further out to the edge. I know ONAP and Airship are looking at some things like this. And Akraino's sort of looking at some of that using pieces of Airship and ONAP and everything. So,
Do you know if the Crano folks are using the CI/CD from OPNFV?
I don't think they've gotten that far yet in their discussions. So this was a slide that actually we presented a similar demo at ONS last week. So I got to do a live demo on stage twice. Only once did sirens go off. And so this is a slide from China Mobile where they were talking about sort of the scale of their mobile edge and how they were thinking about it with their national level data centers, their provincial data centers, municipal, county access, and then their base stations with their numbers. So this is the largest wireless provider in the world. So their numbers are pretty extraordinary in terms of how many servers they're looking and sort of the latency expectations they've got kind of at each hop. So China Mobile was really involved in helping us kind of pull together, and they've been very involved also with OAI in the development of their EPC and some other things. And so we're starting, so we can say we're kind of starting with trying to solve their use case. Speaking of CI/CD, they're using actually OPNFV CI/CD as an infrastructure. They're looking at that as a possible infrastructure deployment. China Mobile. So using those tools to get some of the the NFVI infrastructure out there.
So AT&T should also be looking. I was president of the board.
Yeah. So.
We'll let the Akraino folks decide.
Yeah, I've been talking about
Yeah, and that,
it. Realize all this stuff.
So in terms of the providers, and this gets into kind of, what we did accomplish in this demo, things that we set out to accomplish, though we didn't. This is a smaller session, so we can, look at this. So this was a set of service provider requirements. Obviously, the distributed hyperscale deployment model for data center and CO, so, we don't want to do things differently. Flexible and agile, OpenStack and/or Kubernetes. We did not get the cloud native stuff working this time, partially because the other thing that OEI did, and I'll get into that in the network demo, is they actually, the 3GPP CU/DU splits that they've started doing, OAI has actually sort of brought the CU and DU into software so that you can deploy your CU/DU in different places according to which of the splits that you're interested in. That was a big piece that we got working. Right now, and that's in one of my slides I'll get to, some of that software only runs in a VM. They haven't even thought about how to start containerizing some of that yet. So that was part of the reason we didn't get much further down the cloud native path, is that some of the pieces just, they were just getting virtualized, and people haven't even started thinking about how to design them in a cloud native
So,
fashion.
in ONAP, there's a 5G use case that's coming out in this,
Yeah.
Casablanca.
Yes.
The name of it.
Yes, and there are, and
So I guess when that happens, then you can like.
yeah, then we can sort of, kind of bring these together, because we started working on this pretty much after the Beijing summit last year. So we were also working with the pieces that were there at the time. We did do some upgrades to OpenStack while we were doing it, but a lot of the pieces around the specific 5G next-gen mobile core, like they were being developed over the course of this demo as well. So, and that's the OEI work.
This is really confusing. So we have all these use cases, and they're all in all these different fiefdoms, if I call it that.
Yeah.
But each fiefdom is focused on like specific areas. Nothing. And then when you add them all together, then it actually is comprehensive.
Yeah.
It's really.
Yeah, I mean, there are, because there are different people. I mean, like especially developing some of that stuff, the OAI kind of components, like the CU/DU split, the software-defined radio, their open source VEPC, like they're very focused on that. I think they work most closely with China Mobile and Orange. There is a new ORAN alliance that's come out, and they're going to bring the open source software sort of pieces into the Linux Foundation. So some of the conversations I'm having right now are kind of, is,
They don't fit no nap, they don't fit no
yeah,
NAP, then, oh, I see.
like where the, is your seed code going to be some of this, to kind of figure out what their expectations are with that, because I know some of the people with that are working with OEI, and from what China Mobile gave an ORAN presentation last week, and part of what they were saying is their expectations from the ORAN open source were basically hitting these pieces.
And so they see that coming into LFN?
I think that that's still being worked out, to be entirely honest. I mean, OPNFV works with CNCF and OpenStack, so I know we can work with people even if they're not in LFN. I think they're still working it out. I think that they might choose to go somewhere else or just be at the LF level, partially because there's still so many licensing issues when you start talking about RAN in the mobile space. And so I think they're just wanting to kind of take care of themselves with that and be in a special place. But I don't know that, because I think they're figuring out. I do know that IPR issues are more complicated the more access network that we get, especially in mobile. And I know that that's a thing that we're really working through at the same time that we're developing the software. I know that the licensing on OAI, for example, is not a traditional OSI open source software license, but it's the best that they could get.
Probably like, what is it? You know what the license is?
It's honestly a custom license that they sort of design themselves based on an OSI license with what they could get basically some of the other people to agree to. So I think there are some open questions about whether, what we're going to do with licensing there. And not being a lawyer, I can't can't say exactly where we're going. I know that I'm hearing this from pretty much everyone, and it's funny because I'm talking to open source people at the NEPs who are all like, they've gotten the Apache religion, and then they still have an entire IPR legal team whose entire idea is patent portfolio management. And so, I tend to be more of a sort of interested in the technology development person, but I do know that as we advance here, there's going to be a lot of lawyer to lawyer.
What happened here with OCPREG18?
Yeah.
Right, that discussion was.
Yeah.
Of the licensing, like,
Yeah,
discussion.
yeah, and so you're,
Remember in the early session, I said this is why CHIP has a different IPR policy than the
Yeah.
OCP. And this is the same kind of deal. They're able to carve out, okay, this is agreeable, okay, fine, let's go for it, to let people participate even though they have issues.
yeah,
Yeah.
yeah. Yeah, and so a lot of this is still very like frontier. We're trying to figure out how to get parties involved, how to bring them to the table, how to keep pushing around the edges of kind of moving to more mainline open source kind of things. So so the other requirements I think are relatively straightforward. But so the things that we actually did in this demo were actually sort of demoing vRAN, CRAN. We are also showing the low layer and high layer split. And that's a lot of the work that OEI was doing, as well as the Cordis VEPC. Low latency services, we did do some basic network slicing. We originally had some ideas for some fancier network slicing that we just weren't able to get to. We also wanted to get to a point where we could do some more VoLTE and also containerize actually some of the IMS out there. And right now, none of the IMS are quite at that stage, so that was a little bit difficult. We did, as I said, rather than deploying ONAP and using ONAP for all the onboarding, we did kind of more basic Ansible, which could be a question of do we want to. Does ONAP want to look at some more simplistic onboarding for applications as well? I won't comment on that, but and then we did have a mix of bare metal and VMs. The split things,
So on Intel, you also got ARM.
This was all on Intel, so I'll get to the hardware in just a second. So here's sort of the network diagram we've got here with the RAN, the EPC components, and sort of kind of virtual the C, basically kind of showing the CUDU splits there. All right, moving along. So we had two labs. Our main lab was hosted by Cumulus. And we were going to have OCP hardware provided by Penguin, but it got stuck in customs. So this is a very vanilla, but it's still pretty vanilla Dell x86 hardware here. Mellanox provide the switches, leaf and spine fabric, and then our kind of typical provisioning jump host gateway there that did the open stack provisioning of all the other nodes. And then we had a Faraday cage with some handset UE hardware, and then some, an antenna provided by, so they'll be on a slide, and then the software-defined radio coming from OAI. And OAI software-defined radio can do 5G with the right sort of antenna hardware, but we wanted to show the call-on stage, which didn't have that either. So, as I said, this was very much like a picking off pieces that we could advance. A lot of stuff is still in process in terms of its availability for a full comprehensive 5G network demo, but we picked off the pieces that we could just as a proof of concept and what we could start integrating into the CI/CD pipeline. And then we had a virtual branch, which y'all saw on stage during the demo, and that was provided by Circle B and MyTac. And so they had a Wi-Fi access point in there, 10 gig switch, And then this was sort of Circle B's kind of solution, and they got the sleds from MyTac that were open rack compute sleds in, I believe, a 19-inch sort of enclosure. With shared power, and there's some empty bays. And actually, I was just downstairs on the show floor, and we're looking to maybe put some of Nokia's sleds in there, so we can show multi-vendor OCP in a common enclosure. And this is going to be going into the OCP Amsterdam kind of experience center that I think Steve was talking about during the keynotes, and we're going to see if we can get a more an easily sort of usable version of this demo going in there as well, so that folks can kind of see this. This is more information on the MyTac sleds and the ESA chassis and network card, so the way that they got the sleds into the 19-inch rack. And so then here's our demo topology. So this is in San Jose in the Cumulus lab. So they've got the software-defined radio going into the little handsets, the RU, the DU, which were bare metal, managed by OpenStack, and then I believe the CU was a VM, and then going out into all the sort of like EPC aspects, we had the PGW connecting to the internet, and then through OpenVPN going to the branch there on the Amsterdam stage. And there's a picture of some of the racks that were there in Cumulus. And so when we did the demo, do I have the cool animation? I have a cool animation. All right, so basically what we did is because we couldn't put anyone in the Faraday cage to like initiate a call. So what we did is we turned on one, connected to the internet with an internet streaming music service, turned on the other phone with, both of them had speakers on so we could hear the streaming. And then basically, so the internet was coming into one phone, connecting to the other phone, coming through the cellular network, going to the PBX on stage, and then onto the handset that I answered.
So when you did this, the
Yep.
CO was where? Is
This-
everything in,
So the CO was in San Jose, California, and then the branch was on stage here. All right. Pictures from last week, cage to the stage. We weren't going to do the demo again. So a couple lessons learned is actually it was fairly difficult to get hardware from folks. Also, kind of getting the understanding of the specifications diagrams, how much compute we really needed up front. We went through several iterations of this that kind of gave us some false starts. We had lots of people saying they were sending us hardware, kept getting caught in customs. But the thing is that the software did all work, interoperability. Like once we actually got down there, the OAI stuff, because that was the most cutting edge, was some of the sort of most difficult because they were finalizing releases like up until 2 weeks ago. But they did get it work, and we did get the proprietary VNFs, the OpenStack, the Open Daylight, and then all the other pieces interacting pretty seamlessly. And as Bill mentioned, once we had it sort of a lot of the pieces working in the San Jose lab, we were able to configure the branch office fully remotely in the Amsterdam data center in just a couple days. So we did like a lot of the integration work we did up front that was kind of painful. It was pretty easy once we got to setting up what needed to go on the branch here. One of the things that we're in the process of doing now that we've made it through both these shows is we're going to write a solution brief talking about this, and we're going to include a cookbook in there for how to deploy this more easily. And then a couple things. We started with Pike. We needed to go to Queens. Pike couldn't support some of the things we were needing to do here. We ran into a couple bugs. So you do probably need to be using Queens if you want to do this.
what's Pike and
OpenStack releases.
Queen?
Yep. We went from P to Q since they're in the alphabet. We did, you do need pretty beefy machines. I don't know the specs off the top of my head for the DU and BBU functions. And so the RU definitely needs to be on bare metal. Bare metal are containers for the DU, and the CU VMs are containers. We're still trying to get the CU application even sort of possible to be containerized right now. So that's on their roadmap. These are ways to get involved, and I just want to talk a little bit. So we are looking to continue to evolve this demo. We want to get ONAP roped in the future. I want to get the ORAN Alliance folks roped in the future. Acrino started about 2/3 of the way while we were through this to kind of figure out, where Crano wants to be in this mix. But we have a couple projects that have been going on in OPNFV. We've had an Edge project for a while. It's a little dormant. China Mobile has just started a CRAN project where they're wanting to do some CRAN proof of concepting that maybe gets upstreamed, kind of the way we upstream stuff to OpenStack in the past, that they can upstream into ORAN and OAI. And the Rocket project, that might be interesting to some of the hardware folks here. That is a project China Mobile launched specifically to start looking at special edge hardware, so FPGAs and GPUs and things like that, making sure we've got interoperability. I also know DPDK has a project specifically around this. DPDK's done a lot of work to work across ARM and x86 and Open Power and Mellanox, et cetera. So I know that there's work in DPDK where they're trying to make sure they have the right abstractions so that they can work across that. And so we're going to be partnering with them as well, but just beginning to kind of understand deployment considerations for that kind of special hardware. I also think that there's some work we can do with FIDO VPP, maybe as we're looking toward cloud native, maybe the network service mesh group in CNCF. So these are sort of where I'm seeing work happening that we want to do in the future. But these are some of the projects going on in OPNFV. As I said, we got the open source VEPC deploying now regularly in CI/CD within OPNFV, and I think we want to see which other of these pieces we want to operationalize into our regular CI/CD. OAI has a lab that just finished building out a lab that they're going to make available to us. The Cumulus lab is going to transition to a Penguin-hosted lab that they've just built out in San Jose, and it's going to be available to be sort of a Pharos lab for these kind of use cases. And then the OCP Amsterdam lab, they want to sort of get involved in this. So we've got some more lab spaces for this kind of use case work that we're trying to get the CI/CD in. And we had an interesting talk with OAI last week about how do you even start doing CI/CD for like access stuff and software-defined radio and things that are touching maybe quickly iterating hardware. So very, very kind of like figuring out new stuff around CI/CD type things. And then OCP's obviously got their networking and server projects. And I know a lot of people are interested in seeing this in different form factors and figuring out which OCP things they want to put into their COs or even further edge things. So I know that that's active discussion here. We just want to make sure that we understand kind of the software deployment aspects within LF networking. And I think someone had a tip question. We haven't yet worked with tip, but I've started a couple questions to see some of the tip access projects, if we want to, how they might fit into this, especially if we really want to show real 5G over open source hardware and open source software end to end. But that is still a little bit TBD. And once again, these were the companies involved. Edis Research was the company I was forgetting earlier. They provided the antenna that we used that could take the OAI software-defined antenna. And then, and these were the open source projects that got involved in it. So, all right, any questions? Doing questions through here. But yeah, I mean, it was definitely, we were working with some software that was not quite ready for prime time at the beginning, so it was kind of cool to see it actually come together and work and work on the OCP stuff. Getting it working on the OCP hardware was pretty much very easy. So, and I know we're looking to kind of continue to evolve this and start deploying, kind of use those labs that have now been set up through this demo to start doing it on a more regular kind of automated tested basis. And we'd love for folks to join the party if you want.